It's me, talking to you about stoichiometry, which is reaction proportions, the proportions we use for reactions. There's cardboard boxes everywhere. Let's get into some science. So as you can see, stoichiometry has a few different purposes. I've written them down. They're kind of similar though. We could use stoichiometry if you want to make a specific amount of a chemical. Let's say we know a chemical reaction and we want to make a specific amount of one of those products. Dog, we're going to use stoichiometry. Or if you want to know how much of a chemical to use in a chemical reaction, dog, we can figure that out using stoichiometry. Or if you really want to know anything about the proportions used in a reaction, we're going to use stoichiometry, which tells us about the reaction proportions, the proportions of chemicals we use in a reaction. Let's look at a more specific example of that. Oh, that clap did nothing. Let me try again. That clap seems to have done something. So here we have an equation, chemical, and a problem or a question. So I want to make 1,000 grams of iron, Fe. How many grams of Fe2O3, iron 3 oxide, will I need? If you're going ahead in your head and saying like 1,000 grams, because we want 1,000 grams of iron, so we need 1,000 grams, you're wrong. I'm sorry, you're wrong. And this is where stoichiometry comes into play. But to do this, I like to use this cool dude diagram. Diagram, could you come on over here? Thank you, diagram. Oh, look how beautiful it is. So with this diagram, I can plan out stoichiometric conversions. Thanks, diagram. In this case, I know what I want. I know that I want 1,000 grams of iron. I would put this, because I know this, I would put that on my known side. Wait, is the known side here? The known side is here. I can't tell. It's so hard to film things. I stopped freaking out. Okay, great. So I want to get to an unknown thing. But I know that I want to use 1,000 grams of iron. So I would put that over on my known side of this, because I know that's what I want. What is unknown is how many grams of this iron oxide I would use. So I would say that iron oxide owns the unknown side of the diagram. And let's see, if I know that I'm using 1,000 grams of iron, well, grams is a measurement of mass. So I would say to myself, I have the mass of this guy, and I want to know how many grams of iron oxide, another grams. Grams is a measurement of mass. So I want to go from my known mass all the way over yonder and come along this way to my unknown mass. Fabulous. This diagram is super useful because it has the conversion factors we need already in it. Mwah, I love it. Mwah, mwah. So let's make that diagram maybe up here, I don't know, like down here on the board. And we'll like do the problem. Sick. We'll model how to do it. Let's make that thing appear like meow. I think, did I do that good? I hope I did it well. Anyway, we can see that diagram here. It's much smaller and not as pretty, but we can still see it. We've got moles as our central guys on both our known and unknown side. And so we said, what I like to do with these diagrams, my dear humans, is I like to label the fork out of that guy. So I'm going to put additional labels on it to help me out with this problemo. So my known side, we said, I know that I want this amount of stuff. So my known chemical is also, I'm going to say that that is iron, Fe. And my unknown chemical, the one that I want to know about, is this other guy, this iron oxide, this Fe2O3. That means the mass, if this mass, I look at that mass, I'm talking about the mass of Fe2O3. If I look at this mass, I'm talking about the mass of iron. And I already know the mass of iron that we should be basing all this off of. I know that I want 1,000 grams. I know that the mass I want is 1,000 grams. And I know, well, I don't know, but I do want to know the mass of iron oxide. So I want to know this. I'm going to put a little question mark there that tells me this is where I'm trying to get to. Using this diagram is really nice because it can help us organize what steps we're going to do. Every time we cross one of these arrows, that's going to be another step. So my first step is going to be to convert from the mass of iron to the moles of iron. And then from there, I can convert from moles of iron to moles of iron oxide. If you're uncertain how to do that, we're going to get into it because this is some new stuff. And from moles of iron oxide, I can convert to the mass of iron oxide. If you're really fuzzy on how we do these mole mass conversions or mole volumes or mole particles, dude, check out that video that I made that other time about stuff and things, specifically how to deal with these conversions. Check it out. But we're sallying forward with this. So what we should do probably is erase this actual problem because it's taking up a ton of space, and we should write down our steps for this in a nice list, and then we'll get cracking with that. Let's make it happen. Actually, let's go through and write out our steps. So I got rid of the actual question up here, but I still kept that we want 1,000 grams of Fe. That's what we know. And our unknown thing is the mass, the grams of Fe2O3. Well, our first step, as I said, if we know this right now, this is going to be our starting point in our journey. And we can only move across the arrows. So my first step, the only thing I can do is convert from my mass of Fe to my moles of Fe, because that's all I can do. Mass is stuck. All I can do is change into moles. And if I want to get over here to my unknown country, well, my second step is going to have to be what? If I want to move in this direction, I'm going to have to go from moles of Fe to my moles of the Fe2O3. So my second step will be moles of Fe, and I'll change those to moles of Fe2O3. Well, we're still not at our desired endpoint after 2 steps. After 2 steps, we'd have gone wah-ha, and then wah-ha. We need to get to our desired thing, the grams, the mass of this Fe2O3. So I think we're going to need a third step, step 3. And in this one, we're going to take what we just had, or just calculated, our moles of Fe2O3, and we can convert that to our grams, or the mass of Fe2O3. Fabulous. Let's just write the word mass in there so we're consistent in our steps. Beautiful. So by using this diagram, I've been able to figure out what steps I need to take. And the version of this diagram that I'm going to sum it up to the screen, or that I summed up previously, also shows us the conversion factors. Between mass and moles, we need the molar mass. Between moles and moles, we need the coefficients from our balanced chemical equation. And then again, between mole and mass, we need the molar mass. However, here, I need to use the molar mass for Fe2O3, because we're in Fe2O3 iron oxide country. And for this conversion, I need to use the molar mass of iron, because we are just regular Fe, or iron country. So let's, my dudes, go ahead and make it happen. Wow. Time for this. So I've got a line set up for a fraction that I'm going to fill in with each of the conversion factors. The conversion factor I need for step 1, the conversion factor I need for step 2, and the conversion factor for step 3. Wow. So to go from the mass of something to moles, I'm going to need to use the molar mass. And my desire is to get moles. So moles should be my new unit that I get. And the grams of the mass is the thing I do not care about anymore. So I can look up my molar mass for iron. Wow. And I can say, oh, wow, 1 mole equals that many grams. So 1 mole goes with how many? 55.85 grams approximately. Wow. So my first step can be accomplished by taking 1,000, multiplying by 1, and dividing by 55.85. But you know what? I'm going to string all this together because it's classier. And so we can jump right into step 2. In step 2, I'm converting from moles, it looks like it says males, but it's moles of iron to moles of this Fe2O3 iron oxide. And you know what? To do this, my dudes, we need a balanced chemical equation. Because if we check out this diagram, it says right around there that we need one of these balanced chemical equations. So let's take a quick break, and get our equation balanced. I think it's balanced now, right? We've got 2 aluminums on the reactant side and 2 aluminums on the product side. Beautiful. And we've got 2 irons on the reactant side and 2 irons on the product side. And 3 oxygens and 3 oxygens. That's a balanced baby. Well, I needed to do this because I needed the coefficients out of here. If I want to change from moles of iron to moles of iron oxide, let's see. My old unit will be moles of iron, and my new unit will be moles of iron oxide. I'm going to use the coefficients out of my balanced chemical equation. The coefficient that goes with iron, Fe, is 2. So I'm going to pop this 2 in there. Again, 2 is the coefficient, the number out front that tells me how many of this I need for the reaction. That goes into my conversion factor when I'm changing from moles of one chemical to moles of another, as long as they're part of a balanced chemical equation. And so what coefficient do I find with iron oxide? Well, there's no number there, so I assume it's a 1. A 1 when it is no coefficient shown. Beautiful. So this is what I will do for my second step to convert from moles of iron to moles of iron oxide. I can move on to my third step, and as I said, if I'm going between moles and mass, or mass and moles, I need the molar mass. And the molar mass for Fe2O3 is this beautiful boy. Wow, so beautiful. And I know that I want to get rid of my moles. I'm trying to convert from moles to mass at this point. So I want moles to be my old unit that goes down below. I want mass, or grams, to be my new unit that goes up top. And I know that there's 1 mole that goes with every 159.7 grams of this fabulous iron oxide. So what does this come out to? What does it come out to? So I'm going to do 1,000 grams of iron times 1, which does nothing, divided by 55.85, that does something, times 1, does nothing, divided by 2, wow, times 159.7 divided by 1 gives me a fabulous answer of about 1,430 grams of what? Grams of Fe2O3, grams of iron oxide. So, dudes, that was a little bit of a process. That was a little bit of a process. But, my dudes, we can do all this fabulous stoichiometry stuff. Just takes a little bit of thought and a little bit of planning. And that's why I'm all about this here diagram guy, because it can help us with that planning. I use the diagram to help me figure out what steps am I going to take. The diagram also shows me what conversion factors I need. So as long as we're comfortable using that diagram, we should be money. Let's look at another example. Bye. Wow, look at that problem. Pew, 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 it's up there. So in this problem, we've got ourselves a nice balanced chemical equation, and we have ourselves a question. How many liters of CO2 will be produced by burning 100 grams of C3H8? So for starters, we need to figure out what do we already know and what is our unknown. Well, it's pretty clear our unknown thing is what we're being asked for. How many liters of CO2? So our unknown is going to be our CO2. And liters of our CO2, we want to get to our volume of CO2. Well, if we check out our diagram, there it is. There's only one way to get to a volume of CO2, and that's if we already know our moles of CO2. Well, we don't know anything about CO2 in this problem right now. All we know is that we are burning 100 grams of C3H8. So our known bit right now would we know we've got 100 grams of C3H8. So I need to somehow fill in this gap. Well, if I want to convert from one chemical to another, I have to go from moles to moles. I can't go directly from my grams of C3H8 propane to CO2. I first have to convert this to moles of C3H8, and that's, dudes, real talk right now. You're pretty much always going to have to convert to moles. So if you're given a value and it's not in moles, you pretty much are always, not always, but 99% of the time are going to want to convert that to moles. So I'm going to take my grams of C3H8, I'm going to convert that to moles of C3H8 from there using my balanced chemical equation. I can convert from moles of one chemical to moles of another, and then I can get my last bit done. Hey dudes, I'm going to make that diagram appear on the screen right there. Why don't you give this problem a try on your own? Beautiful, you tried it out. Well, let's go through it together. Because I have 1, 2, 3 different conversions to do, I'm going to break this up into step 1, step 2, and yeah, you guessed it, step C, because damn the rules. No, now. We'll make it step 3 just so the internet doesn't get too mad at me. And in step 1, I'm going from grams of C3H8 to moles of C3H8. That's nice to know. In my second step, I'm going from moles of my C3H8, my propane, to moles of CO2. Okie dokie. And in my last step, I'm going to be going from my moles of CO2, fresh out of the step 2, to the volume of CO2. Beautiful. We'll go from moles of CO2 to that volume of CO2. Sick. So I know what I'm doing for each step, or at least what needs to occur. Each step is going to require its own conversion factor, and we can find those on our diagram. If we're going between grams and moles diagram, what do I use? Thank you. I use that molar mass. So I'm going to need the molar mass of propane. If you don't remember how to get molar mass, check out this video. I think I actually referenced it. It's the one on moles. Yeah, I already referenced it. I can't make the thing appear. So rewind or go to my channel. Find it. You can find it. So in this case, I need the molar mass of C3H8. I'm going to use that by looking up the mass of each element on the periodic table, adding together the respective molar masses. I know for this guy, my molar mass is approximately 44 grams per mole. 44 grams equals 1 mole. Let's see. If I'm starting off with 100 grams of C3H8, and my first step is to go from grams to moles. Moles will be my new unit. The grams will be my old unit, so I'll put that into denominator. If you don't know why I'm doing it this way, check out my video on just generally doing conversions. Great. Go watch that if you don't understand this. But since I said there's 44 grams per mole, 44 is the number that goes with grams, and 1 will go with mole. 44 grams for every 1 mole. Fantastic. So after I do this mathematical operation, I should have completed step 1. So for step 2, I want to go from moles of my propane to moles of the CO2. To do that, what do I need? Thanks, diagram. I need to use the coefficients from my balanced chemical equation. Ta-da! And let's see, my old units are going to be these moles of C3H8. My new units are going to be these moles of CO2. And in my balanced chemical equation, let's see, 3 is the coefficient that goes with CO2. So I'll put that 3 with CO2. And I don't have a number out here, so I'll put in a 1. And you know what? I can just write in a 1 right now. If you feel like doing that, if it makes you feel better, go ahead, dude. Do it out. So I'll put this 1 down here. And now, with this in place, I have my mathematical operation for step 2 complete. If I wanted to go through all this, I'd take 100 and multiply by all my numerators and divide by all my denominators. Well, step 3, let's see. I want to go from moles of CO2 to volume of CO2. Dear diagram, what should I use for that? Thank you. The conversion factor, 1 mole equals 22.4 liters. Well, let's see. I want volume. Volume is measured in liters, so I'll pop my liters as my new unit up top. And moles are what I want to get rid of, so I'll pop my moles down below. And let's see. We said 22.4 liters equals 1 mole. At this point, I am ready to go through and do all my fabulous maths for all my fabulous steps and get some kind of fabulous answer. What's that answer going to be? Calculator, can you help me out? Wow. Yes, we can see it comes out to 100, we'll call it 153. And what are the appropriate units to put on this? Let's think about that really quickly. I start off with grams of C3H8. Well, I have grams getting divided by grams here, so those guys should cancel out. And I've got moles, but these get divided by moles here. And C3H8 is being divided there. If I start with C3H8 and I divide by C3H8, anything divided by itself cancels. So this guy is going to cancel out as well. So now I'm left with, what units are left? Just moles of CO2. And I divide by moles again. So these moles are going to get canceled out with these moles. So all I've got left are liters and CO2. My answer is 153 liters of CO2. Wow. Cool, dudes, cool. So, by using that funky, fresh diagram, we can come up with a plan, and then using the conversion factors in that diagram, we can execute our plan to come up with an answer. I'm trying to keep this video short. Let's keep it short. Ta-ta and have a great rest of your... Wait! I hope you liked this video. If you liked it, go ahead and smash like. And then take something else you love, maybe a calculator, and just smash that dude as hard as you can. Don't smash your stuff. Just smash like, subscribe. Ta-ta, have a great rest of your life.